Now, so far what we've done is we've talked about matrices, then we did scalar multiplication. We talked about this in previous chapters, and we did it again in this chapter. Just multiplying a matrix by a scalar, a number. We followed that up with addition and subtraction. And we followed that up with multiplication, and those were kind of the operations we did. We also talked about determinants and using determinants with Cramer's rule. But these three here are the main operations that we've covered so far. The only other real operation that we're missing is what? Because we have addition, subtraction, multiplication, division. Now, it's not possible to actually divide two matrices, but what we're going to do instead, and kind of a little shortcut around it to be able to divide, is using something called inverses. We can take inverses. Inverses are going to be our kind of quote-unquote division, because we can't actually divide matrices. Now, for a matrix to be an inverse, for one matrix to be an inverse of another, the multiplication, the product of the two matrices, should give us the identity matrix. And it also works out that the identity matrix times anything will give us back to what we have. So if two matrices are inverses of each other, when we multiply them together, we will get the identity. So if we said A and B, let me go back a page. So if A times A inverse, if they are inverses, will be equal to A inverse times A, which is equal to our identity matrix. An identity matrix is going to be any matrix that has a diagonal of ones and everything else is zero. So this here is what we would call the identity matrix. Now we can actually have a 3 by 3 identity matrix, or a 4 by 4, or a 5 by 5. Doesn't really matter what the dimensions are as long as it is square and we have this diagonal of ones. So no matter what the size is, the identity matrix is going to be this matrix that is all zeros except for a diagonal of ones, like this here. Or even if it is a 4 by 4, we get this here. So if two matrices are inverses of each other, their product will give us the identity matrix. If it doesn't, then they are not inverses. So really what we're looking at is to determine whether these two are inverses. But what we're going to do is we're just going to multiply them together. And if we wanted, or what we could do is we could actually plug these into the calculator. I could type these into the calculator and get what their product would be. I could set one as A and one as B and multiply them together. Or we can do this by hand. And when we do this by hand, we're going to go over and down. So our first one's going to be negative 4 times 1/4. And then 2 times plus 2 times 1/2. Then again, we're going to go over and down. Negative 4 times negative 1/2 plus 2 times negative 1/2. Or over, down, over, down. This is just repeating what we did last week, yes? Any questions on this so far? Any questions on anything we've done so far? We're going to do the same thing with the next row, over, down. So we're going to have negative 2 times 1/4. plus 1 times 1/2. And lastly, we're going to go over down to our -2 times -1/2 plus 1 times -1. So far all we've done is we're just multiplying these two together. That's what we're doing. And what we're hoping to get is the identity matrix, because if I can get the identity matrix, then these two matrices can be inverses. Now, -4 times 1/4 is going to be -1. And 2 times 1/2 is going to be, well, plus 1. Our next one, -4 times -1/2 is going to give us 2. And 2 times -1/2 is going to be -1. And going down to the next row, -2 times 1/4 will be -1/2 plus 1/2. And lastly, -2 times -1/2 would give us +1. And 1 times -1 would give us -1. So any questions on how we got to this point here? Any questions on any of this here so far? Okay. So lastly, we just need to simplify this here. And once we simplify it, we'll see where we're at. Well, -1 plus 1 is 0. 2 minus 1 is 1. -1/2 plus 1/2 is 0. And 1 minus 1 is 0. So is this the identity matrix? No. No. So what that tells me is that these two here are not inverses of each other. So here our matrix A and B are not going to be inverses of each other. It doesn't work out. This does not work. These are not inverses. Because as here, these are not inverses. And we're done. That's all we have to say for this year. Because all we're checking right now, all we're doing at this point so far is seeing and determining whether the two functions, or two matrices, not functions, two matrices are inverses. If they are inverses, we get the identity matrix. If not, we'll get something else. All right. As soon as I get one matrix, after multiplying them together, that's not the identity, we're done. They're not inverses. It will not work. Okay. So let's do it again with this here. 3, -2, -5, 6. 3/4, 1/4, 5/8, 3/8. Myself a little bit extra room. Now we're going to multiply these together. Now if you find it easier doing this on the calculator, that's fine. Because for the homework and on the test, if you want to do this in the calculator, perfectly fine. Go use that. Here we're going to do it by hand. I'm going to do it by hand. So we're going to do our over down. So we'll have 3 times 3/4, which would give us 9/4, because 3 times 3 would be 9 over 4. Then we'll have plus -5 times 1/4 will be -5/4. And that'll be our first spot. Then we'll do the same thing, over and down. So 3 times 5/8 would be 15/8. -5 times 3/8 will be -15/8. So plus -15/8. Or you can say -15/8, either one. I mean, they're going to be the same thing. Plus and negative or just minus is the same thing. Any questions before we go to the next part? We're going to do the same thing over and down. So negative 2 times 3/4 will be negative 6/4. And yes, negative 6/4, we can reduce it to negative 3/2, but we can leave it as negative 6/4 at this point. There's nothing wrong with that. 6 times 1/4 is just going to be positive 6/4. And lastly, over, down. Negative 2 times 5/8 is going to be negative 10/8. 6 times 3/8 is going to be plus 18/8. Any questions on how we got to this point here? Any questions about this multiplication so far? Are we good with this here? Yes? Okay, let's simplify. What is 9/4 plus negative 5/4? 4/4, which would be 1. So this would be 1. Then we have 15/8 plus negative 15/8, which would be 0. 15 minus 15 is 0. Negative 6/4 plus 6/4 is. And lastly, negative 10/8 plus 18/8. Well, I would simplify to what? 8/8, which is 1. So I'm left with what? The identity. Yes? All right. And we talked about multiplication. Was f times g always the same as g times f? Well, no, not in matrix multiplication. Because if I have a 3/2 and a 2/3, well, these would multiply together, so that works, and I would end up with a 3/3. Yes? If I switched it, a 2/3 multiplied by a 3/2, so I just flipped them. Well, it works, and what's my new product? A 2/2, yes? Multiplication with matrices is not closed, so order matters with matrices. So that means I also need to do, I'm going to use a different color, 3/4, 1/4, 5/8, 3/8 times 3, negative 2, negative 5, and 6. So we're just going to do it the other way. Now, if you did this in the calculator, it's easy to do both ways because, well, it's just recalling it again and multiplying. Now, if we do this multiplication over and down, well, the first one's going to be 3/4 times 3, which will give us 9/4. Okay, this is kind of lining up just like the one before, yes? Now, let's see the next one. Well, that would be 5/8 times negative 2, which would be negative 10/8. Okay, now it's a little bit different, isn't it? Okay, well, let's keep going and see what happens. Then we do 3/4 times negative 5, which would be negative 20/4. Actually, not negative 20/4, negative 15/4. Five eighths times 6 is going to be plus 38. Okay, now we're going to go to the bottom row. 1/4 times 3 is going to be 3/4. 3/8 times negative 2 is going to be negative 6/8. And lastly, over and down, 1/4 times negative 5 is going to be negative 5/4. And 3/8 times 6 is going to be plus 18/8. eighths. I know I went a little bit quicker with that one, but essentially we're doing the same thing, our over, down, over, down. As soon as I know one doesn't work, the other doesn't matter.
Okay. So they have to work for
Yes, for two matrices to be inverses, A times A inverse is going to be equal to A inverse times A, which is equal to the identity. As soon as I see that A times A inverse does not equal the identity, it doesn't matter about the other because all of them have to be the identity. Mm-hmm. Yep, so as soon as I get one that's not the identity, we're done because it doesn't work. Now we want to check both ways just to make sure. Most likely, if it does work one way, it's going to work the other. Now, if you notice this here, I mean, at this point here, if you wanted to, if you're doing it by hand, you could plug these in a calculator. Calculator has no issue with doing fourths and eighths. But I can't just subtract them. I want them to be the same. So I'm going to have to change all the fourths into eighths by multiplying it by 2. That would give me 18 eighths for the first, because 9 times 2 is going to be 18. 4 times 2 is going to give us 8. I'm going to do the same with the next one. Well, negative 15 times 2 would be negative 30. 8 plus 30 eighths. If I do it with 3 fourths, well, that's going to give me 6 eighths minus 6 eighths. And lastly, negative 5 fourths times 2 over 2 would be negative 10 eighths. Well, out of all of these here, there's 2 of them that are easy to pick out. It's going to be that negative 38 plus 38 is going to be 0. They're the same thing, they cancel out. And 6 eighths minus 6 eighths would give us 0. Well, 18 minus 10 is 8, and 8 divided by 8 is, so we get the identity. So FG times GF equals the identity. So yes, these are inverses. Because since they're product, going either direction gives us the identity, they are inverses of each other. They are inverses of each other. Any questions on this here? Any questions on any of this here so far? Okay, we good with this here? Now I want to show you something interesting with the identity matrix. I'm going to take the matrix 3, negative 2, negative 5, and 6. And I'm going to multiply it by the identity matrix. So if we do this multiplication, we would go over, down. Well, 3 times 1 is 3. Negative 5 times 0 is, well, 0, yes? So let's do the next one. Over, down. Well, 3 times 0 is 0. Negative 5 times 1, well, that'd just be minus 5. Yes? Let's do the next one. Over and down. Negative 2 times 1 is negative 2. 6 times 0 is going to be plus 0. And last one, over, down. Well, negative 2 times 0 would give me 0. And 6 times 1 is going to be plus 6. Well, didn't it give me back what I started with? Whenever you multiply by the identity matrix, it will give you back exactly what you had before. It doesn't change anything, which is kind of helpful. Questions on this here? Do we feel comfortable determining whether two matrices are inverses? Yes? Pretty much plugging it into the calculator. Okay. Now the last thing that we're going to do today, we're going to finish these note sheets tomorrow, is finding the inverse. So for a matrix A, B, C, D, we're going to use this formula here to find the inverse. And the inverse exists as long as AD minus BC is not equal to 0. Because if this is equal to 0, the inverse does not exist. Now, other than that, we're just plugging this in. We're filling in for A, B, C, and D. Now, the first thing we have in finding the inverse is 1 over AB minus AD minus BC. AD, BC. Well, that's just the determinant, isn't it? Diagonal going to the right, diagonal going to the left. So this here, AD would be 7 and negative 1. So we'd have 7 times negative 1. Minus, our other direction would be our negative 5 times 2. Any questions on this here? Any questions on any of this here so far? We good with this here so far, yes? Well, this negative and negative, if I wanted to, I could rewrite it as a plus. Because a negative and a negative make a positive. Okay. Now let's look at this matrix. Well, A and D did what? They switched places, didn't they? Because in our formula, we now have D, negative B, negative C, A. D and A switched. So in our matrix P, A is 7, which means 7 is now in the bottom corner. Negative 1 was D, so now it's up in the top corner. So we switched those two numbers. The number that's in A's position is now in D's. The number that was in D's position is now at A's. So these two here switch. They switched. Well, B and C are now what? Negative. So we switch the signs. So since negative 5 is up here, it's now positive. And since the 2 was positive, it's now negative. So really we just have what? 1 over the determinant. Inside the matrix we switch A and D, make the other two negative, or switch the sign. Any questions on any of this here so far? Okay, now we're going to simplify down. Well, 7 times negative 1 will be negative 7. 5 times 2 is going to be plus 10. So we're just really simplifying that fraction out front, the scalar, and then we're going to multiply through by that scalar. Well, negative 7 plus 10 is positive 3. Any questions on any of this here? All right. Well, the last thing we need to do is we just need to multiply through by this 1/3. And if I do that, well, 1/3 times -1 will be -1/3. 1/3 times -2 will be -2/3. 1/3 times 5 will be 5/3. And lastly, 1/3 times 7 will be 7/3. And this here is the inverse of matrix P. This is its inverse, is this here.
Got to the point where you're at the 1/3 times the matrix.
Mm-hmm.
You put that in the calculator.
Yeah. You all seen this button here on the calculator, yes? X to the -1. Really, you could type the matrix in and use this button, and it would actually give you the matrix. You might have to use our math and then fraction, because it's going to give you it as a decimal to convert it over. But that will also give it to you. Any questions on this here so far? So when you type it into the calculator with that inverse, you type the one we start with. So if you want to give it a try on the calculator, we'll do this next one here. -8, -6, 12, and 9. So if we wanted to do this, we could store it in the calculator as matrix A, and then do A inverse, and it would give you the inverse. Now, if we're doing this by hand, we're going to have 1/AD times CB. So that would be -8 times 9 minus -6 times 12. Well, here the negative and negative would make a positive. So that's fine. Now inside the matrix, we saw that A and D switch places. So A and D, well, that'd be -8 and 9. So the number up top would be 9. The number down here would be -8. Those two, A and D, switch places. In the formula, A and D switch places. And B and C, we switch the sign. So since B is -6, since it's negative, it's now positive. Since C was +12, it's now -12. Any questions on this here so far?
Can I put A and inverse to the calculator? It just said it was an error.
Okay, let's see what happens. So -8 times 9 is what? -72, yes? And 6 times 12 is any questions on any of this so far? Well, what's -72 plus 72? Can we ever divide by 0? No. So this one here does not have an inverse because its determinant is 0. Really, if the determinant of the matrix is 0, then its inverse does not exist. So the determinant of matrix Q for this here is equal to 0. So its inverse does not exist. And that's it. That's all we have to do for this here because it doesn't have an inverse. This one here is not invertible. Questions on this here? Let's look at one more. Do you all want to look at 2A or 2B? 2A or 2B? 2B or not 2B? That is the question. 2A. So we'll look at 2A here. So if we want to find its inverse, so we're going to do this by hand, so we're going to use the formula. So we're really going to have 1 over its determinant times our matrix when we switch and change signs. So we have 1 over A times D. So that would be 3 times -4 minus 7 times 1. 3 times -4 minus 7 times 1. Now inside the matrix, again, we're going to switch A and D. So 3 and -4 switch. So the first number is going to be -4. Our number down here is going to be 3. They switch places. We flip them. A and D switch places. B and C, we change the sign. Well, since the net 7 was positive, it is now negative. Since the 1 was positive, it is now negative. And that's it so far. Any questions on any of this here? Okay. Now we're going to simplify and solve. Well, 3 times -4 is going to be -12. -7 times 1 is just going to be -7. -12 minus 7 will give us -19, so we have -1/19 out front. Which brings us to the last step, which is just really multiplying through the entire matrix by -1/19. So we'll do -1/19 times -4. Well, the negative makes it positive, and we'll get 4/19. -1/19 times -7, the negative and negative give us a positive. 7/19. -1/19 times -1 will be positive 1/19. And -1/19 times 3 is going to be -3/19. So that there's our answer. And that's it. That's all we have to do for this here. Any questions on any of this here? Anything we've done so far? Are we good with all of this here? Yes. And I mean, we could have typed this in as matrix A in the calculator as A inverse, and then done our math fraction, and it would have given this here also. So we could have done it in either way. And that brings us to the homework assignment this here.